A very good morning to Vidit Kumar, sir.
Yeah, yes, madam. Am I audible?
Yes, sir, audible, sir. Sir, we'll start the session in few more minutes. 30 participants have joined till now. We'll just wait for 2 or 3 minutes, sir. Then we'll start the session, sir.
Okay, no issue.
Thank you, sir. Good morning to all the participants. A very warm welcome to day 5 session. Today we'll have the talk about recommender system, and it's a practical session. It will be given by Professor Vidit Kumar Patra from NIT Roorkela. A very warm welcome to Vidit Kumar sir to take this session on day 5 about recommender system. Before hand over the session to Dr. Vidit Kumar, let me introduce him. So it is our pleasure to have you as a resource person to this ACT sponsored short-term training program on machine learning and deep learning techniques for AI problems using Python. Dr. Bidyut Kumar Patra, he is working as an assistant professor in CSC department at NIT Roorkela. He received his BTech and MTech degrees from University of Calcutta, and he holds PhD in CSC from IIT Guwahati. Dr. Bidyut Kumar Patra is having 20 more years of teaching experience, and he worked in Haldia Institute of Technology, Tejpur Central University, and now he is currently working as an assistant professor in NIT Roorkela. Dr. Bidyut Kumar Patra, he did postdoctoral in VTT Technical Research Center of Finland, Finland. And Sir has developed a laboratory for educational technology in NIT Rourkela. Dr. Bidyut Kumar Patra is expertise in intelligent computing and computer vision group. His areas of interest includes data mining, machine learning, and recommender systems. And he received many of the projects from various funding agencies like SIRP as a principal investigator. And he developed a project called Development of City Traffic Dashboard using social media data and historical GPS trajectory, and a sponsored project titled Development of Psychocognitive Recommender System for Weak Learner in Flipped Learning Scenario. And he is also as a principal investigator received a project titled Development of Pathological Healthcare System for Early Detection of Neurological Joint Abnormalities. And he received one more project from DSG also. And Sir is having 37 plus publications in international journals and conferences. And his citations are 370 in number. And with this long list of achievements, now I would like to invite Dr. Vidyut Kumar Patra to take over the session on recommender system. Sir.
Good morning to all. I think I am audible to all.
Yes,
Uh,
sir.
with big listing, generous introduction, I am really happy to be here with you. Thank you, madam. Thank you, the organizer, especially Dr. Rao. And
Thank you,
and
sir.
today's class, actually, I wish to correct a little in the introduction part. Is actually I will be talking on the theoretical part, not the laboratory part. Maybe I want that some things should be developed, and then maybe later on we can go for the laboratory for in future. And another thing is the last before the last project, the pathological part, I was the co-PI, not the PI. Okay. Apart from that, everything is fine. But I am really happy to be with you, with learned person like you, and then I saw many professors also among us. So, with due respect to the senior professor and my colleagues, I consider them as a friends here. So, I'll go with my today's talk. So, I am comfortable if I switch off my video. So, I think it won't be any problem. Yeah, hopefully my screen is visible to you.
Yes, sir. Visible,
Title,
sir.
yeah, I changed my title a little bit here. So apart from the whatever I communicated or madam said here, so that is introduction to recommender system at its recent trend. I am very much fortunate to be contacted by Dr. Rao. Thank you to Rao. I think Rao is also will be here.
Yeah. Thank you,
Yeah.
sir. Thank you very much for accepting our invitation.
Okay, yeah. So here I'll be talking on three major topic. One is introduction to recommender system and different type of recommender system. I'll be mostly focusing on this part, and then I'll talk about the recent trend in recommender system, and then I'll touch upon what we are doing at my lab, that is Intelligent Data Analysis Laboratory, NIT Rourkela, and recently we rename it Educational Technology because I have 2-3 projects from the related to educational technology. So yeah, that first screen you can see here that a lot of headphone you can find here is really confused which one should I purchase. This is another way we can say it is we have the huge information, but we are perplexed to choose which headphone should be suitable to me. So this is something called the information overload. So more formally, that is information overload is a scenario where the consumer are unable to make a right decision on a product due to too much of the available information. So to cope with information overload, the recommender system is introduced in, let's say, in beginning of 90s. Yeah, recommender system help people cope with information overload problem in this digital era. As you can see some figure here, Amazon, and then I will be talking next in details. So application of recommender system nowadays is quite huge. So as we can see on the OTT platform and e-learning courses and electronic products, and we know that Amazon and then of late that Flipkart also started providing a personalized recommendation. So the term personalized recommendations is very important. Let me clarify. Recommendation and then personalized recommendation. Okay. So yeah, sorry. So then there are many application of just sir, I am in a talk, sir. Okay. So some application of recommender system is Netflix, Amazon, YouTube, Spotify, Book Crossing, Yahoo, and so on. Okay. Yeah, I will spend some more time in this on this slide here. So there are different recommender systems have been developed from the beginning of 90s. So those recommender system can be categorized based on the input provided to the system. So as you can see, can I put in a full screen mode?
Yes, sir. It is better if it is in full screen mode. Yes.
Is it visible?
Yes, sir.
Oh, thank you. So now we have the three major category of the recommender system. One is content based, another is collaborative filtering, and another is hybrid of these two. So now in case of the content based filtering, the input based on the input provided to the system, we categorize them. So in case of the content based system, so it has the input from the user profile and the item profile. So in earlier days, in case of the content based system, so once user needs to register with the system, so while registering, user should provide the input information like say user ID, age, PIN code, occupation, and so on. So ideally, one has to fill a form and then only he can register with the system. And then how content-based system work? Content-based system, it works, it basically matches with the preferences of your users along with the item profile. So item profile is, let's say if I have a t-shirt, so item profile will be what will be the color and what is the size and so on, and those will be the profile of the item. Now if I like the color red color, so then maybe that recommender system will match my preferences with the product color, and then it will recommend to me. So but as you understand that it is not very easy to provide the description of the item. Let's say I have a short video, so it is really very difficult to describe the video in general. Okay. And then on the other hand, user profiles, and nowadays people are reluctant to fill up the long listing form for registering any one of the site. And then another issue is that I don't want to disclose my age and I don't want to disclose my occupation. So in that scenario, can the recommender system really help us? So considering this all problem, so content-based filtering is moved to the another category of filtering, that is called the collaborative filtering. So collaborative filtering basically is address those problems. That is what I said. Key is I'm reluctant to provide the information to the system, and then similarly some of the scenario the users item profile is really difficult to extract. So collaborative filtering is a different kind. So it works on the rating data set. So what happens in the rating data set? So user, once we purchase the item or we consume the item, so user should give some kind of rating. Okay. Based on those rating on the item, so it works on collaborative filtering provide the recommendation that we will see how it works. Okay. So and if you observe very carefully, that no need to give any kind of information about the product. Okay, so it only says key whether user like the item or dislike the item, and grade maybe how much it likes or dislike it. Okay, so this entire matrix is called the rating matrix. where user see these rating metrics can be expressed in different way in say I consume the news, so then how many times I consume the news, so that may be the rating here. So ideally the collaborative filtering does not need any content information, whereas it needs a similar kind of metrics, so that can be extracted from some other way, or at the end of the day, so collaborative filtering it required a matrix, okay, of where the user and items information will be there. Okay, so as I said, for review from the review of the users also one can extract this kind of metrics. And on the other hand, that is hybrid recommender system. It basically it takes the advantage of the all the tables from here. Like say, it sometimes it use the user profiles, item profiles, if it is possible to extract, and then obviously reviews all together. It use hybrid based approach. As we'll be seeing later on, that collaborative filtering is really good, and it is really famous in academics as well as the industry up to certain point of time. Now people started exploring the other features from the other domain, like it's collaborative filtering cannot address there is something called the cold start problem. So but whereas the content based filtering is really good, so hybrid filtering, so they use the all type of features here and then come up with a solution. Now for the all type of for each type of recommender system, finally they predict the rating for the unrated item, and then say if I have 100 items, and if I already purchased five of them, so obviously those five of the five items, no need to say whether those items are good or bad to me. I know I have the experience. So the recommender system ideally provide the recommendation, the item which I didn't consume them. Okay. So among the 95 item, recommender system ideally say which item I like best. So out of 95 item, so obviously I'll be system should provide some top n item. So let's say top 5 item which I will be purchasing. So that is something called top n recommendation. Maybe later on I will be talking more in details. So now what you do it, we'll focus only on the collaborative filtering, okay, because this is more famous in academic arena, as well as I said, then and up to some point of time it was famous in industry also. Yeah. So collaborative filtering can be divided into two major categories. One is called neighborhood based approach. One is called the neighborhood based approach, and another is the model based approach. So neighborhood based approach was introduced first, and the model based approach was introduced in late after 2007 or 2006. Okay. So therefore, first we know what is neighborhood based approach. Again, neighborhood based approach will be divided into two parts. One is user based and the item based collaborative filtering. So on the left side of the screen, this diagram is for the user based. On the other side, this diagram for the item based. So let me explain here how the user based collaborative filtering work. And please note that, I would like to mention that collaborative filtering it works with only the rating data set. So now here we have the set of users here, and we have the set of items. Okay. Now essentially recommender system will recommend some of the items.
It's not audible, sir.
Oh. Okay. Hello?
Sir, you're audible, sir. Please continue, sir.
Huh?
You're audible,
Yes,
sir.
sir, you're audible.
Sir.
You're audible.
Okay, good. Okay, I am going fast, or it is okay?
Okay, sir.
Okay. So here we have a set of users. As you can see here, there are two girls and one boy, or two men and one man. So, and there are some of the items here. And then let me explain this figure here. If the dark line indicates that these are the items consumed by the users. So therefore, this girl or this woman, she has consumed this all four items. Okay. and then this girl also consume one item here, that is the strawberry. Okay, so now task is that, so I have to, a recommender system should provide recommendation for these users. So this guy also has consumed two items here, you can see. So this is, I think, watermelon, and this is strawberry. Okay, so therefore, so this guy has consumed these two items. Now we should provide the recommendation, so other two items, so we should provide that which item should be recommended to this guy. So now if I follow the neighborhood based approach, so what we do it, so I'll find the neighbor of this guy. So neighbor of this guy, so there are two women here, so who will be the neighbor? So neighbor, in a sense that whose preference will be very close to this guy. So then how do you decide these preferences? We'll see the what are the item consumed by both of them. Let's say this strawberry, so this strawberry is consumed by this girl and this girl also, and then some other item, this watermelon is consumed with only this girl. So therefore this girl will be more closer to this guy. So therefore now what you see is, we'll see what are the item consumed by this girl. So obviously this two is already consumed for this boy, so we won't consider for this. Now the other two items not consumed by this guy is orange and then strawberry. So therefore these two items can be recommended. Now based on that, these items, either this item or this item can be consumed. So therefore we have to decide that which item should be recommended to this user. So hopefully I can make you understand how the neighborhood based collaborative filtering work. So basically what we'll find for a users for which we want to find the recommendation, very often we say that user is called the active user. Okay, for the active user we need to find who are the neighbors, and then we have to find the neighbors, what are the item consumed, and then out of those set of item we should recommend to this guy. Okay, so on the other hand, I will elaborate this one in the next slide. Okay, with one concrete example. On the right hand, so it is something called item based collaborative filtering. On the left hand, it is user based collaborative filtering. When we use the term user based, so always we find the neighbors of the user. On the other hand, when we talk about the item based, we'll find the neighbors of the item. Now what was the task? Task was, I need to recommend the item to this guy. So therefore, in case of the item based collaborative filtering, what I have to see, what are the item consumed by this guy. So here in this figure I see this item consumed, only watermelon is consumed by this guy. Now what are the other items are here in this diagram. So I think this guy also consumed the strawberry. So what are the other items consumed? This grapes is not consumed, and then orange is not consumed. Then what I have to see, whether these two items can be recommended to a user, this active user. What I do it, whatever the, say these item, what are the non-rated or non-consumed item, so that I will try to find the similarity between non-rated or non-consumed item with the consume item. Let me repeat this part. So I feel I am going little fast here. What I said ki, for this user I have to see what are the items are consumed by these users. So here in this example I see watermelon is consumed by this guy. Now what I do it, so whether I want to recommend the grapes or orange, what I do it, I will find the similarity between grapes and the consume item, and then I will find the similarity between orange and the consume item. If the similarity value is very close, then I will say this item is close to this non-consume item, and therefore the closest item should be recommended to this guy. So this is all about the item based collaborative filtering. So in summary, So in user-based collaborative filtering, we'll find the neighbors of the users, and in item-based collaborative filtering, we'll find the neighbors of the item. Okay. Now I'll elaborate this part with two more slides here. So on the left side, we can see traditional item rating matrix, where users rated the item on different items. So in this example, we have 5 items here, and then we have 5 users. So user E1 rated with 5 on item I1, and similarly for item I3 with 4. And similarly, there is some of the space you can see blank. So blank indicates that user did not purchase this item, so therefore he did not give the rating. So we don't know the rating for this one. Okay. So now what is the task? Task is we have to recommend the item to user. Let's say here active users, find the similar user of the active user. Let's say active user is U4, for whom we want to find the recommendation. So now you can see this guy has rated 3 items, and he did not purchase these 2 items, that is I4 and I5. So first task, whether I4 can be recommended to U4 or whether I5 can be recommended to U4, we have to find. So now how do we find? So first task is we have to find the all unrated items. So in this example, we have unrated item is I4 and I5. Now I'll check whether I4 can be recommended or not. So if I check, for that, what I do it, I will predict that this guy what rating he can give for the item I4. To calculate that, what I do it, I will find the user use corresponding neighbors. So how do you find? So first we find the users who have rated the item I4. So who has rated the item I4? I4 rated by U1, U2, U3, and U5. So all user rated the item I4. So first task, we have to find the user who have rated the item I4. So now we have to find the similarity between U4 with the all users who have rated the item I4. So we compute the similarity between U4 with U1, U4 with U2, U4 with U3, and U4 with U5. Okay, so find the similar user of the active user, that is U4, who rated the target item I4. So in this example, U1, U2, U3, and U5 are the target item. Okay, so once we find the similarity, now if the similarity value is greater than 0, we'll take only those users. Or if I say we'll take only the k most users, so we'll consider only k nearest users. So out of these 4 users, maybe we can consider only the 2 users. So then we'll consider only the 2 users who are the close to user U4. Once we consider this set of users, now we'll go for the rating prediction for the I4 on the I4 item for user U4. Now here standard formula we generally it is used. So this user-based collaborative filtering was introduced in beginning of 90s, as I said. So to be specific, I think it is 92 at MIT. Okay, by Resnick. Okay, so now what we do it, we will predict this rating. How do we predict the rating? So let's say for U4, U1, U2, U3. So these are the users which are close to U4. Now we'll see what are the ratings this set of user gave on this item I4. So we can see this is 1, 3, and 4. So we can take the average of this rating. So this will be 8 divided by 3. Okay. So then rating will be 2.66 something. Okay. So therefore U4 that rating prediction will be 2.66. So this is one simplest way. Another way is that user U3 might be very close to U4 with compared to all the users. So therefore U3 should be given more priority with compared to other users. So therefore in the equation, what we do it, that similarity value between the active user. So in this example, active user is V, active user is U. So we compute the similarity between U and the all neighbors here, and then that should be multiplied with one factor. What is that factor? So it is the rating given by the user V minus the mean of the user V. Let me here explain. What you do, we consider the user U3 is much closer than U4. Okay. So then similarity value you should compute. Similarity value obviously it depends. So it is range is -1 to +1. That is why if it is greater than 0, we should consider. Now what you do it, this guy has rated this set of item, we will compute the average, and then what rating he has given, so that is 4. So 4, so this RVI is nothing but 4, and then this average. Why we are taking average? So average is frequently taken because see some of the guys are really critical to give the good rating. Okay, so you are also experienced that you do not give, some of the professors is very reluctant to give the good rating, even the students are really good. So that means he expect that maybe we'll get the much better students in future, or we expect that he will get much better item in future. So therefore always base rating is reserved for in future. So therefore if you take the average of those rating, so it will be say below, it will be below 4, it out of scale say 1 to 5. Okay, so but some of the faculties they give good rating, or some of the user they give good rating for the all item is rating is between 4 and 5. So therefore average is above 4 or very close to 5. Okay, so to capture this part, whether this user is very critical, whether this user is very lenient for giving rating, so what you do it, this mean is computed. So otherwise if you take the absolute value, so if I give 4, but 4 actually indicates it might be the 5 for some other users. So therefore it is better to always subtract the mean and then multiply with the similarity value, and then whatever the value, it should be range between 1 to 5. So therefore it is normalized. And obviously the role of U4 should be taken. So therefore mean of U4 is also considered here. So now what is the task? I4 we computed. Similarly for I5 also we'll do the same thing. Similarly if you have more items, so we'll do the same way. And among the all non-rated item or unrated item, we will choose, say we should recommend only 5 items. So then among the all unrated item, we only recommend the 5 items which have predicted rating is best 5. So this is all about the user-based collaborative filtering. Now we'll move to the next, that is the item-based collaborative filtering. So now what is the task? We have to, task remains same, that is I have to recommend the user U4 with suitable item or recommended item. So then task remains same, but whether I use the user based and the item based, so that results might be different. So therefore task is remains same, that I have to recommend to user U4, and the item remains whether I will recommend I4 and I5. What I do it, ideally in case of the item based collaborative filtering, and please note that item based collaborative filtering is basically used in industry. It is reported in 2005 or 2003 one journal. So Amazon used the item based collaborative filtering, but there is, after that there is no report that exactly Amazon which recommender system they use. So anyway, so come back to the our task. So how do you do it? I will find the similarity between non-rated item, that is unrated item I4, with already consumed item by the active user. So already consumed item is I1, I2 and I3. So then I will find the similarity between I4 with I3, I4 with I2 and I4 with I1. Okay. So what are those items will be very close to I4? So let's say I2 and I3 are very close to I4. So then what you do, it rating is 4, 5, and I will take the average of 4 and 5. Okay. So then this prediction will be 4.5. Similarly for I5, what I will do it, I will compute the similarity between I4 with already consumed item, and here also you see, let's say I1 and I2 are the closest item to I5. So then, so this rating will be 4 and this rating will be 4.5, And then if I recommend only the item, only one item, then obviously I will prefer to recommend the item I4 because I4 has the highest predicted value. So in summary, for item-based collaborative filtering, we'll see only the neighbors of the item, and user-based collaborative filtering, we'll see only the neighbors of the users. Now, while talking about the neighbors, we said we should compute the similarity value between user to user and item to item. So here, how do we compute the similarity? So in case of some other domain, data mining, we have a very clear idea to how to compute the similarity value. But here we have some problem. Problem is like, see, mostly in rating data set, 99% data value will be 0. Okay, so therefore it is very difficult to compute the similarity whatever have been used in the using those similarity whatever have been used in the data mining area. So one example is here. Say suppose we want to compute the similarity between U4 and U3. So please try to understand the problem here. So we know the items rating for U4, but we don't know the rating for the U3. And then for U2, I1, I2, we know the both the rating, and I3 also we know the both the rating. Similar scenario for I4, we know the rating for U3, but we don't know the rating for U4. Similarly for I5, we know the rating I5, but we don't know the rating for I5 for U4. So now what happened if you want to compute the value of U3 and U4? Okay, we cannot assume this is the zero value. Zero is having some value, but this is a null value. We don't know actually what value that U3 could have given if he or she consumed. So therefore, what we do, simply we have to neglect this rating. So therefore, we have to choose only the items rated by both of them. So in this example, so items rated both of them are I2 and I3. Okay. So only these information will be used while computing the similarity between U3 and U4. Okay, that is the traditional recommender system. So of late, some paper we can see the people are trying to do or trying to utilize the rating for this scenario. Like only one of the two users has used the rated this item, but other user did not rate this item. Now question is, how do we compute the once we identify that only the correlated item we can find the similarity here, but what similarity value, but so which similarity metrics should be considered for computing similarity between a pair of item in recommender system? So we have a list of table we have a table which consists of different similarity measures. So one is the Pearson correlation. So Pearson correlation basically gives the value -1 to +1. So therefore you have to discard the value if it is negative value, because negative correlation means actually, so both the users are not neighbor, they are actually rival, you can consider. Okay, so then how do you compute? Here is similarity value between a pair of user U and B. We have a very standard formula for Pearson correlation. Only my point is that, so in traditional, in other than recommender system, while you compute the Pearson correlation, so they take the all ratings or all values. But here we cannot take the all values because some of the values of null, so then you have to discard. So in summary, you have to take only the correlated item and then you have to use here. And then Jacquard was introduced in 1889. So that is really good measure. So it does not consider the specific rating. So whether the rating, whatever the values of rating, if it rates with 5, is same as the rate with 1. So therefore, it only consider the how many common item divided by union of those set of item. Please note that IU is the set of item rated by the user U. And in 2002, so one different similarity measure is introduced, that is something called, see these all Pearson correlation, Jacquard, and those are very old, say more than 100 years. but adjusted cosine is a variant of cosine similarity measures. So that was introduced in 2002. Okay, so here is little difference. If you see the formula on the right side here, say if that mean difference is not there, so let's say in mean difference is not there, then it is mean difference is not there, it is exactly the same at the cosine similarity measures. Okay, but adjusted cosine similarity, as I said, ki some of the users are very strict, some of the users are very liberal for giving rating. To capture that that is to capture that part, actually adjusted cosine similarity within the similarity measures also, this mean is subtracted. Okay, so that is adjusted cosine measures. Okay, now we talk about the user based and item based collaborative filtering. So yeah, so another direction of or variation of collaborative filtering is called the model based approach. So model based approach is something like that in decision tree kind of thing. So when model is built, not only decision tree, so we have work with so even though a neural network or support vector machine, so all can be categorized as the model based approach, apart from the only the nearest neighbor based approach. So in model based approach, what it is actually done, so a model is built out of the entire training data set. So and then once model is built, then no need for original training data set, and using only the model, we can predict the class level and so on in case of the data mining on machine learning algorithm. So similarly in deep learning also, what you do it, so on networks is trained, so no need to have the original training data. So this is our model, and then whenever the new or unknown objects come, so we identify the class level of the unknown object. Similarly, in case of the recommender system, in model based approach, so once using the training data set means here is rating data set. Using rating data set, we make a model, and then once model is built, so using the model, we provide the rating. So this is one model based approach is called slope one predictor. So it was introduced in 2005 in a conference, that is the Siam Data Miners conference. So this is a really good conference. Okay, so idea is very simple. In 2005, so what is that? Say users A has rated two items, that is item I and item J. So ratings are 1 and 1.5. Now user B, he has rated the item I, and can we predict the rating for user B on the item J while giving the rating of the another user on A on the same set of items? So this is the problem here. So what they suggested, so what is the rating difference between these two items from the same user? So rating difference is say 1.5 minus 1, so that is 0.5. So they are expecting that these rating difference from the same user will continue. So therefore rating for this user will be 2 plus 0.5. So that is the rating will be 2 plus, that is the rating difference. So then we expecting that user B for this item will be given the same rating, that is 2.5. As I said, the user, the teacher who is strict, he remains strict for across the subjects. Okay, so having this idea, they said is we can compute the prediction, giving this scenario. Okay, now for a set of item, or pair of item, not set of item, for a pair of item, we have a many set of users. Okay, so then we have a set of user. For each user, we compute this rating difference and we take the average. What is the rating difference? So what is the rating difference for across the users? Now whatever the difference is there, so that should be added with this value. So in this example, we have shown only one user, there may be another user C, and then rating difference should be 0.6. So let's say here we give 2.6, here we give 2, and then rating difference will be 0.6. So here is 0.5, here is 0.6, and we take the average. Okay, and that value, so let's say 0.55 should be added with 2, so therefore rating for user B will be 2.55. Okay, so that is the idea in case of the slope one predictor. So therefore here deviation between item I and j are computed. How deviation is computed? It is the same way for the all users. So yeah, for all set of users, we'll compute the rating difference, that is RUI minus RUJ divided by the set of all users. Okay, so and then this is something called deviation. Okay, so that deviation should be included. That deviation should play a big role while computing the prediction. So therefore prediction for these users, as you understand that user B, he did not rate only one item, he rated many more items. So therefore instead of adding only the hardcore value for particular other item, so you take the average of those items. So you take the average, so that will give you the average of these items, and then what is the deviation, and you compute here deviation from this item with this item, deviation from this item with this other item, deviation of this item with other items, and all items are rated by the user B. So therefore how many items he has rated, it should be divided, and that average deviation should be included, should be added with the average rating, average rating of the users. Okay, so that give you the rating value at this point. Okay, yeah. So then there is other variation of slope one, that is something called weighted slope one predictor. So while computing the deviation or while computing the prediction, we did not take that a particular item or a pair of item rated by how many users. So it is always good to take the how many users rated the particular pair of item. So then that give you the more confidence. So let's say maybe say a pair of item rated by 5 user, so with rating 55555. So therefore it seems that this item is really good item, but number of user is 5. So other item, let's say other item, let's say one movie, that is Titanic. So Titanic, if you see that movie, so Titanic with some other movies, okay. So if you see that number of user rated, let maybe 1,000 with 5. So therefore, if you see the number of user rated both the item or a single item by 1,000 users with 5 and another item rated by only 5 user, so therefore reliability for the more the user it rate. Okay, so that should be considered, and they consider in the weighted slope one predictor, and then there is other variant of the slope one predictor here. So now I'll talk about model based approach, and model based approach actually become famous. That is something called the metric factorization. So that was introduced in 2009. Okay, this is really famous, and then in looking into this part, that is metric factorization. But as I said earlier, that industry, they do not disclose actually what type of algorithm they are using in for. As usual, metric factorization will have the input, that is user and then item ratings, and then this matrix will be divided into some lower rank matrix. So in this example, what you do it, so users and then item, these matrix will be divided into two different matrix, and once you multiply it, so the dimension will be maintained here. Okay, so then here we have the three features for each item, and then features for the users, for same three features for the user, for each user. But please note that we don't know the what are the names of those features. So this is something called implicit features, or it is something called inherent features of the feature of the item, features of the users and item. So it may be, say, let's say I like horror movie. Okay, so myself is users and movie is item. So therefore, what we can compare is these features. So horror is one feature, and how much horrorness I like in a particular movie. So that may give you the some value. So this is maybe horror features. So that is 0.5. And another similar features maybe for this movie. Let's say some horror movies for this particular feature indicates this feature indicates that how much horrorness is there. Similarly, if I compare these items features, but what essentially it does, key both user and item are placed in the same space and then start comparing. Okay, here is one figure here you can see is see yeah, seriousness and then escapist, and then based on the movies characteristics we can divide we can rate these different movies. So how much seriousness, Braveheart is a serious movie, and then similarly we can put the users here. Okay, so whether is how much geared towards the male and then how much geared towards the female. So essentially what it does ki item and user are placed in the same dimension and you start comparing. So this is the main part of the metric factorization. For doing so, we have some mathematics here. So that is metric factorization techniques for recommender system. So that is a famous paper published in 2009. So we minimize the rating. So wherever non-rating is not there, so that means in a rating matrix, user item rating matrix, what we do first, we predict what rating it can be, and then what is the exact rating is there in the user rating matrix, and then how much that difference will give you the rating, and that we need to that error we should minimize. So initially we start with any arbitrary value, and then we gradually we move one by one using gradient descent approach. Okay. So to refine the results, we added more. This is one thing here, regularization parameter, and then we use this remove the biasness of the item and users. Okay. So that are the basic what is called the introduction or maybe traditional recommender system. Now whatever I will be saying, so that will be the advanced part of the recommender system. So recent trend in recommender system. So long tail items recommendation. So if you see that some of the items received huge popularity, that means huge rating from the users, and some of the good item, even though might be good item, but good item in the sense ki user may like it. Okay, so long item recommendation, item which receive very few ratings. Okay, so cold start user or item recommendation, users or item recently added into the system, and then diversity is recommending diversified item list to the user to maximize the liquidation. Okay, so let me tell you what is long tail item recommendation. Long tail item recommendation is something, say, as I said, ki it is in general it is fine that 80% of the item receive very less number of rating, where 20% of the item rating 80% of the total rating. Okay, so therefore, and the present day recommender system basically they recommend only the popular item. Popular item are those 20% item which receive the which receive or 80% ratings. So, but present day recommender system basically focus for recommending only the long tail item. Sorry, focus only the popular item. And then what is the long tail item? Long tail item are those item that is 80% item which receive very less number of rating. So those items are long tail item. And then what is the cold start scenario? Cold start scenario is something like that. Say I am new to the recommender system, so my history will not be there. So system does not know that what are the items are consumed by the users. Okay, what are the items are consumed by the user? Those consumed by me if I am the new user. In that scenario, the recommender system cannot recommend to me Okay, so that is something called the cold start user. Similarly, there will be a cold start item. Why cold start item? The items which are not which the item just launch in the system, so then no one purchase those items, will not have any kind of rating in the system, so therefore those items will not be recommended using collaborative filtering. Okay, so that is something called the user cold start item. And then diversity is is something like that. Say suppose I purchased on iPhone, or I purchased on Samsung phone. Okay. Now, if system again recommend me different companies but same smartphone, so I may not be interested to purchase that type of item. Instead of that, so if a system recommend for different types, say suppose some novel, okay, I might be interested on. So therefore, if the recommendation is also similar kind, so user may not be interested to use the recommender system. So therefore, recent work, that is 2012 onwards, people are focusing more on diversity issues of recommender system. And of late from 2005, people are focusing on long tail item recommendation. Okay. And there is group recommendation. So group recommendation is another scenario where so let's say a set of friends decided to go for a movie. So then can the recommender system or OTT platform can give the recommendation, so that a set of friends can be very happy to watch that movie or so on. So that is something called group recommendation. So this is also another research area, but that is very difficult. As you see, that if 5 friends are there, so each will have their own preferences, and then you have to combine those preferences and then recommend. But obviously, if you go for a tourist place, so recommending the tourist place, mostly people want to go all together. So therefore, say let's say even the within a family also, you can see there may be 4 or 5 person, and each individual has their own preferences. But in this scenario, maybe which tourist spot might be very good, suitable for a family or a group of family. So that is all about the group recommendation. Yeah, then recommendation in social media, so that is friend recommendation. And then point of interest recommendation. Say I know I am aware about the Hyderabad city, whatever they are in the point of interest, so I know. But if I reach to London, so can the recommender system help me to tell that which restaurant should I go based on my preferences, or based on my features when I was in Hyderabad. So this is all about the recommender system in social media. So this is friend recommendation, point of interest recommendation, or maybe many more. And then is streaming recommender system. Streaming recommender system is something like that. Let's say we talked about the user-based collaborative filtering, item-based collaborative filtering, and then we also talk about the model-based collaborative filtering. But carefully, if you observe that user-based collaborative filtering, we essentially compute the similarity. And basically, these similarities are pre-computed. Let's say if I start using this recommendation, I should have computed the similarity beforehand. Otherwise, these are time consuming. And so if you compute the similarity beforehand, so maybe let's say similarity computed a month before, if I use for recommendation, within a month there will be a huge change in the database. So those are not getting reflected in recommendation. So therefore, people are focusing more on the recommendation. Whenever there is a change in user preferences, that should be reflected in recommendation. That is something called streaming recommender system. And then of late, people started working on session-based recommender system. So that work started only from 2016, and now people are gearing off with this direction. There are many papers, recent work we see on the session-based recommender system. What is this? See, if I want to purchase some item, I don't want to register with the recommender system. What I do it, I will go and I will see some of the items. and then I will purchase it. But whatever the system we earlier said, key user item recommendations or user item ratings and profile and so on. So users history must be with the recommender system, otherwise it cannot recommend. But there will be plenty of users, and there will be many recommender system or many e-commerce site which may not have the history of the user. So in that scenario, how the recommender system should recommend. So therefore, as I said, I'll go and I'll click some of the item, or I'll see I'll observe some of the item, and then I'll purchase. So in that case, system does not have my history, only the history I have within a session. So knowing only within a session can the recommender system really recommend to me. So that is all about the session based recommender system. I think I should complete by 11:30, right? I have a meeting again 12 o'clock. Anyway, so long tail item recommendation already I talked. That is traditional RS are biased towards the popular item which receive more rating in the system. So item which receive few ratings are generally not recommended to the users. So these items form a long tail in the product space, leading to a loss in the industry. Say you can imagine you have total 100 items, then 80 items form the long tail. So therefore 80% of the items will not be recommended by the recommender system. So that will be the loss to the industry. So therefore this is a very important topic to work on the recommender system, that is long tail item recommendation. So several models based on the hybrid approaches are proposed in the mitigating the long tail item effect in the recommender system. Cold start is already I said. So user who recently joined the system, new item which do not have any ratings in the system, and then deep learning approach people have started. This is something called streaming recommender system. Traditional collaborative filtering techniques, though efficient, they are not equipped to process the new rating in real time. So user taste and interest change over with respect to time. So therefore, user preferences calculated earlier could become obsolete, and that lead to the concept drift. So what is the feasible solution? So whenever there will be any change of the rating, so that should be updated and that should be included while giving recommendation to the users. Okay. So in this direction, as I said, the work 2005 or 2004 started. So work history is very limited. So yeah, incremental, as I said, that there is a similarity measure called adjusted cosine similarity. And similarity measures, what they said basically, that you make the adjusted cosine incremental. So whenever the new items come or there will be a new rating change, so you compute the similarity instantly. So therefore, for computing similarity, you should have the adjusted cosine, and then adjusted cosine will be much faster, and then item-based collaborative filtering will be will be used for this scenario. So paper published in a really a star conference, that is CIKM. So similar in 2005, that is 10-cent rate. Another algorithm was proposed in 2015, that is also they targeted the item-based collaborative filtering. What they did, see, essentially what we do it, while computing similarity, we have to compute similarity between one item to the all set of items. So they use a probabilistic approach. The item which are already dissimilar, we should not compute the similarity value. So that is their work. And then Subbayan provided a recommender system is called StreamRec. StreamRec also published in CIKM in 2016. So there is a similarity measures. There is a techniques for computing similarity measures. So that is something called locality sensitive hashing. So locality sensitive hashing is also a probabilistic approach which basically finds the closest users and then find the closest user means closest point. So here in this example, maybe closest item for a target item to the target item, and then it compute, and then they showed that the locality sensitive hashing is because it's time constant, so it will make the much faster. But only problem with this, all these measures are key probabilistic approach, so therefore there is a high chance some of the good item might be missed. Okay. Now I will talk about one approach. Okay, so and then I will talk about one very simple idea where in our approach only, and that was published in a conference, core A conference, that is ECIR. So before going to that particular work, so we basically modify this work, that is the tendency based, or we can say key we made the tendency based collaborative filtering in streaming scenario. So let us understand the tendency based collaborative filtering. So this is the paper published in ACM TOF 2011. This paper is so simple that no need to do so much computation, similarity, matrix factorization, and so on. So this paper only computed 4 terms, that is user mean, user item mean, and then user tendency and item tendency. Once you computed these 4 terms from the rating data set, and then you can say what will be the prediction for a particular unrated item. So that is this all paper about. So let's say we have the rating matrix here, but rating matrix in different way. So we have user ID and item ID and the ratings, then user mean and item mean. Once we compute the user mean, item mean, and then from this matrix, so for this information we can make the users and item matrix. So they introduce, apart from this, they introduce another 2 terms. One is user tendency and item tendency. Let us try to understand what is user tendency here. So user tendency here, we computed, let's say for user tendency for user U. What do you do it? User rated set of item. What do you do it? That with particular items, let's say for users U1. Okay. So U1, this user, he has rated I1 and I2. What do you do it? So we'll see the rating on item I1, and then what is the average rating of the item. So average rating of the item is 4. So then we'll 4 minus 4. And similarly, what we do for another item. So this is IU is nothing but the item rated by the user U. So for another item, that is for item I2, the rating is 5. So 5 minus what is the average rating for item I2? Average rating for item I2 is 4.5. So 0 plus 4.5, 4.5, 5 minus 4.5. So that is 0.5. So divided by 2, so 0.25 will be the user tendency. Similarly, for all user, we can compute the user tendency. Please note here, user tendency formula is so simple. What is that? Set of all items he has rated, for each of them, you find the differences from the items rating to the mean of the item, not the user items rating. Okay, mean of the item. So if you say I, so it should be I here. So that is the item tendency. And then on the other hand, item tendency, for item, whenever you compute, you see what are the users that items are rated. So set of user rated by the item I. So whatever the rating, you put it, but that time what you do is, what is the average rating of the users? So basically it is a good item, so that all user rated with 5. So therefore this value will be positive, because good item means average rating of the users will be below 5. Okay, so therefore this value always will be positive. So therefore if TI is positive, that means that item is good for all of the users. Okay, similarly user ratings, if it is a very critical user, say all users is giving positive, say above 5, or sorry, all user giving rating above 4.5, or say most of the user giving 5 to the movie Titanic, and some of the user given rating 3 to the item, or to the item Titanic. So in that case, what happened, that average will be close to 5. Now myself, if I give rating to Titanic 3. So therefore, what will happen? So I am the users which basically different from the rest of the populations, and really I dislike the movie. Otherwise, I would not have given the rating 3. And in that case, what will happen? This value will be negative. So therefore, user tendency is negative indicates that this user is very critical users. He is not liking any one of the item he has rated. So similarly, from these two parameters along with these four, along two, that is user mean, user tendency, item tendency, he said for all items we can give the rating. So and then, so if we want to see the positive, both are positive, then they come up with a formula. Here, if both are negative, they have the formula. So there will be different variation of the user and item rating. Okay. So now, what is the major issue with the tendency-based approach? So item tendency. So if the item is good, let's say a Titanic movie, so that will be good for all. Okay, so that is not possible. I may dislike the movie Titanic. Okay, so here is here we have the objection, or we argue that item tendency cannot be generic. Item tendency should be personalized. Some of the item I like, but you may not like it. So therefore, we said key item tendency should be, for this is on our contribution. So item tendency remain unchanged across the users, leading to non-personalized. Okay. So what we did, we made this that is item tendency. What is that? Yeah, time is like 11:15. Okay, so I have 15 minutes. So item tendency, user tendency, we rephrase it as shown below. So it is very simple work we did it because this work is just very new. So therefore, I think hopefully this was accepted here. Short. Was the objective work was to recommend in streaming scenario. So therefore, user tendency and item tendency, all everything should change while there is a new rating. So therefore, we rephrase it here like that. So let's say this is a formula, so we can rephrase it here, AUBI. Now the scenario is user U newly rate the item X. So if there is a users which rates the rating rates the item X, so therefore there will be change of the item tendency and there should be change of the user tendency, because users average will change, and then this formula should be redefined here, and then similarly that item X item tendency also will change. So that is, we will do it here. This is very simple. What you do it, user you newly rate the item X. So therefore, whatever the value here, so simply we add it here. So therefore, this value will change. Okay, this is so simple. And then what you do it? So here, so this whatever average was there. So this is the new item. Okay, new item. So the and then what you have to do? This is X. X is the item rated. So its corresponding average also will change. So what was the old average? Old average was RX bar. That is already known. What is there? How many item that how many user rated this item? So you simply multiply it, and the new rating, whatever it comes, then we add it. So then and divided by the number of user plus 1. So there we will get the average also here. So therefore, what will be the BU? BU is nothing but the average of the item summation. So now one item's average change. So therefore, whatever the BU value, so what will change is simply new value will put it here. Okay. So because this is a new item, so BU will have another extra term. So this user tendency will be changed very simply. Okay. And then there is another scenario when I change or I give the rating to X. So there will be effect for the other users. So this is the scenario number 2, and then we solve it here. Okay. I am running out of time. Yeah. So we propose also a incremental similarity measures here. And then personalized tendency, we commented that item tendency is not personalized. What we did it, so what we did it, only the items rating here in this formula, what we did it, this was only for the all users rated that particular item. We'll take only those users who are close to the target to the active users, those rating we'll take and then we'll consider here. Okay. So now we'll talk about, very first we'll talk about the session based recommender system. So long-term user model are often not available for a large fraction of the users. Okay, user could be first time to the platform. So session based recommender system relies solely on the user action in an ongoing session. So deep learning based approach are proposed to predict the next item to be recommended in a session. So now why is the session based recommender system, that also I cover. Just little statistics. For a common e-commerce company, more than half of the all sessions are non-logged. That means if you don't give importance to the non-logged user, so your business will be 50, what is that, 42%. Okay, so therefore that you will lose the 57 point those number of users. Okay, I think 38, right? So no past interaction of the users are known. Most sessions are window shopping ones, and where the user are only looking for the product availability, but you have to make it transaction. And out of these, among the 53, only 2% of 2.53% of all sessions are converted to transaction. Okay. So this is the problem statement. Just I'll describe what is the problem statement here. Session-based recommender system, that is, task of the session-based recommender system is to predict what a user would like to click next when her current session is given. That means whenever I not logged for a non-logged users, I'll see the item. Okay, and it should be visible that what will be the next item that I may click. Okay, so that way you can recommender system should guide to the users. So that means, so let's say I click the item x1, x2, x3 and xn. So now recommender system should say what should be the xn plus 1, and then that particular item should be displayed displayed in front of him. So that is something called the session based recommender system. So that is here given, and the prediction will up to knowing up to xn, I will set a set of item, say 1 2 3 4 5 items I should recommend to this user. So that is all about the session based recommender system. So session based recommender system, RNN are heavily used. So I don't have time to describe next here. Yeah, I should. RNN is used, and you know here. So there are some work in first work in session-based recommender system used in deep learning in 2016, and there are recent work. There are many work here. So this is a conclusion, and then recent work that attention mechanism are used for recommending item in case of session-based recommendation. Now I'll talk about what we do at our laboratory. So we work in different direction. Obviously, recommender system is one. So other is anomaly detection, and then cognitive relearning system, and trajectory analysis, and so on. So I'll talk about that another I'll take another 5 to 7 minutes. So we have a project here that as madam also introduced, development of a psychocognitive recommender system for weak learner in the flipped learning scenario. Let us understand what is flipped learning. So left side, even though figure is not very clear, on the left side you can see the traditional classroom where teachers teaching here, teaching lessons, and then students are doing their homework. In flipped classroom, students will prepare the lecture at home from the preloaded lecture video, and while they come in the class, so teacher will be there, but they will do the problem, they will solve the problem rather than only taking the concept from the in normal method. So that is all about the flipped classroom. Now, what is the problem here? Say, suppose if I give a problem to the student could not do. Some of the students could not do. So that may be the problem. The problem is that problem which I gave is top problem, or student did not uh, prepare the notes, or he was not attentive while watching the video. So in this work, what we will do, that is laboratory plan is like that. While watching the lecture video, we will capture the brainwave of the students, and then from the brainwave we analyze the data, and then can we conclude the student was not attentive, and that is why we should recommend that these videos should be recommended to these users. So that is our block diagram. So we have a component here. We'll capture the brain signal, and then we'll modify whether the student is fast, weak, slow, and then based if the slow, weak learner, and then we recommend some of the video. Okay. So, and then for this one, how do we do it? We give a single channel EEG headset, so that will be cost around 8,000, 8 to 9,000. So, and that is everything is done in laboratory. So students come not at the home. Students come here, and then we capture the signal and we are analyzing. So we communicated some of the papers, results is yet to come. So then another work we have is like development of city traffic dashboard using social media data and historical GPS trajectory. Essentially, what we do it, we capture the data from yeah, say now is Twitter handle, and then obviously we should have information from the GPS trajectory also, and we combine them, and then we make a social what is called city traffic dashboard. So this is we are working with Bangalore City. Uh, Bangalore City, why we do Bangalore City people? They are more. They use more what is called. They are tech savvy, and then we found that they are very active, and so that is why we use the Bangalore Traffic Police Twitter handle for extracting data. Okay. And then recently we have a project from NITI, Ministry of Electronics, where what we do it. Here idea is that this is for the primary school student only. So what we do it, we cannot give the mobile phone to the primary school student, but now due to pandemic and situation, everything changed. So idea was that same recorded video will be lecture video will be broadcasted through the cable TV, and then student can watch at their home. So this is the idea of the but as you understand that local language is Oriya, and this region is mostly dominated by the tribal people, and so therefore many school is having more than 60-70% from the SC/ST community. As you know, many of the parents of the students are the first generation learner, so they understand only their own language, even the tribal language. So therefore we have a research component that key whenever we send to information to the guys, that should be automated, and that should be spoken in the tribal and the Oriya language, even though student teachers can speak in English. So that is the NLP part of this project. Yeah, that is the entire diagram. But of late, we'll remove this part, that is cable TV. We'll incorporate here the air fiber instead of cable TV. So that's all. That is the few references. Yeah, for these are my PhD students here, and she is now in Canada, and this guy he's back in India, and my patient students, they help me to develop this presentation. So I think I must stop at this point. If you have queries, I can take.
Yeah. Thank you, sir. Thank you for your insightful information to our participants on the topic given to you. I hope participants get benefited from the talk by getting the basic requirements on this particular context. Now, participants are requested to clarify your doubts if you have on this particular uh, topic given. Sir, there is a query from the participant. I will read it. Can we use the association mining in the context of collaborative filtering? You explained while you explained.
Association, can we use association mining for recommendation? Is it that question?
Yeah. Yes, sir. Can we use association mining for
Yeah,
recommendation?
I did not see any work on using association mining,
Okay.
but no, maybe my answer is not complete. So association mining, while it is computed, we generally compute the association mining across the data set. Okay, so that may not be the personalized. What can be done? But because you asked the question, that it one thing in it came to my mind. What you can do it for a particular user for whom we are recommending. What you can do it? We can find the set of users who are close to this user using some similarity measures, and we can see the what are the items rated by those set of users, and then we can find the association, and then maybe that may be another paper really. Okay, you can work on over it. Okay, hello.
Hello, sir. One
Yes.
more. Yeah, one more query. What is the scope of research in this particular area?
So there are huge scope of work in this area. Okay. So one thing I will actually tell you three topics. One is the long tail item recommendation. Okay. So that work is there is not much work in the long, but don't go for proposing new similarity measure and so on. That is almost say let's say saturated kind of thing. Okay. So it will be good if you work on the long tail item recommendation and streaming recommendation and session based recommendation. Those three new area is really good. Even if one can go for the group recommendation, but the problem is little bit tougher. Okay.
Okay. Sir, can you suggest the popular data sets for this particular topic, sir? Open source
Okay.
data sets. Yeah.
Yeah, there are open data set is what is called is ML data set. So that is if you find the ML what is not ML data set, what is that? Movie lens data set. Sorry, movie lens data set. So movie lens data set is really any paper they report first on is with movie lens data set. Okay. So therefore movie lens data set you can use. There are three variation of the movie lens data set, and there is a Netflix dataset, but you won't get the Netflix dataset because of that case suit in 2010 in USA. So but you can try. Some Chinese guy kept in somewhere, and then I got when I was in postdoc. So that dataset is with me. So if you like, I can share in some way, but I cannot put in public domain. Okay. And session based recommender system is also open. So data set is in this area at least for doing research. Okay, data set is we have a huge data set. So obviously you can contact. So my students are also doing. So they are ready. We are ready to help you at least for giving data set.
Yeah. Okay, sir. Thank you. Thank you for your words, which are helpful to us to proceed in the direction. Any more
So
queries from the participants?
yeah, it is a good number. It is a good number.
Yes, sir. Yes, sir. Yes.
Yeah.
Yeah. That number gives us the energy to give the more.
Yeah. Let me tell you, I conducted one short term, on 3 days workshop or short term course, whatever you say. So initially the number participant was 140, and then it reduced on the last day. We found only 25. So for you, is 80 is really good number.
Sir, actually, daily it is up to 100, sir.
Okay.
Yearly it comes 100. Yeah, that's why whenever 100 is cost, we are giving the second option in YouTube streaming also, because our meet in our institute is limited to 100 members.
Okay.
Yeah, through 2 channels we are offering this lecture.
Okay, okay, okay.
Thank you,
Very
sir.
good.
Thank you for your acceptance and giving the information to all our participants. Hopes some people at least benefited by getting some inputs. It is not possible to give are doing wonders in a duration of 90 minutes. In future also, we are ready to help you in this direction by getting the resources from the speakers like you, sir. Thank you.
Okay, thank you very much, Dr. Rao. Thank you all member of the organizing committee. Thank you all.
Thank
Thank
you,
you.
sir. Thank you. Have a nice day.
Bye.
Once again, we thank you, sir, Professor Bidit Kumar Patra from NIT Roorkela. Thank you, sir. Thank you for your wonderful session. Dear participants, now we'll take a break for 5 minutes. Next session will be on deep learning for autonomous vehicles. This session will be given by Dr. Ailaya Kaveti from NIT Warangal. We'll take a break for 5 minutes. We'll start the session at 11:40 exactly. Welcome back. Now we have session on deep learning for autonomous vehicles. This session will be given by Dr. Ailaya Kavitigaru from NIT Warangal. We welcome you, sir, to this AICT sponsored STTP. Good morning, sir.
Thank you, ma'am.
Yes, sir. Before hand over the session to Ailaya Kavitigaru, let me introduce him. Sir, Ailaya sir is working as an assistant professor in Department of CSE, NIT Warangal. And sir received BTech and MTech degree from JNTU Hyderabad, and he holds PhD degree from University of Hyderabad. And Dr. Ailaya Kaveti garu had 25 more than publications, includes in high indexed journals and various conferences. And Sor is also having some of the book chapters. And Dr. Ailaya Kaveti garu is having 12 years of teaching experience, and he is also a IEEE senior member. Right now, he is guiding two students. Under his guidance, two students are working. So, sir, we welcome you to this STTP to take over the session on deep learning for autonomous vehicles, sir.
Yeah, thank you,
Sir, you
ma'am.
can continue, sir. Yes, thank you.
Yeah, good morning, all the participants. So today's topic is on deep learning for autonomous vehicles. Yeah, yeah, I think I need to share my screen, right? Just a minute. Able to find where is this? Yeah, yeah, right. So before, yeah, I think it is visible, right?
Yes, sir, visible, sir. You can continue the session, sir.
Yeah, right, right. So before this one, so basically, what is an autonomous vehicle? Okay, so autonomous vehicle or autonomous car, whatever it may be. So autonomous vehicle is a vehicle which is having capability of sensing its environment and operating without human intervention, right? So generally, if you if you see this at any time, suppose a human passenger is not required to take control of the vehicle at any time, right? So passenger required to be present. So any time, if you are going anywhere, generally a traditional car means will go like so. We have to, the human have to handle that thing, right? But the situations where actually this one is very important, right? So actually, this autonomous vehicle may be a car or a robotic car or whatever may be the vehicle, right? So which is having some capability of sensing its environment, and it has to move safely. Means like human being, whatever the human being is with the human being, how a car will run. So like that, automated automation also we need to have the system like that. So with little or no human intervention. So generally, if you coming to the levels of automated driving, whatever the research as of now in this field, if you see, there are actually 6 levels we can say it, but the level 0 is no automation at all. Means they have level 0, level 1, level 2, level 3, level 4, and level 5. So for a total of 6 levels of automation is there, but for level 0 we can call it as that is manual control. It means driver with car with driver, right? So that is called no automation. Now coming to level 1, this is a little driver assistance will be there. So this is the vehicle features a single automated system, right? That is it monitors through some control, right? So driver must monitor the driving, means he has to monitor whether it is going in the right direction, whether it is working properly. So if something mishap, something happen, then he has to take the control. But he will leave his hands. Simply that machine will run the car. Now coming to the level 3, that is eyes off. So what is this? Partial automation. We can call it as partial
Hello.
automation. Yeah.
I'm requesting participant NSK who is present here. Stop your presentation. NSK. Someone is present sharing the screen. Please stop your screen sharing. Hello. Anand, remove it. Participant. Sir, Ali sir, 1 minute, just 1 minute.
Yeah, it's fine, sir. It's fine.
Someone is sharing. Maybe accidentally it is happening. We will do it. Sir, now share your screen, sir. Ali sir.
Yeah, yeah.
I'm requesting the participants be cautious while using the gadgets.
So now coming to the this is level 3. Will have a partial automation. So the driver must be ready to intervene within a certain time frame. Suppose if something happened, suppose while moving, the human, the driver can still monitors all the tasks and can take control at any time. Like suppose if the system is not means properly trained, suppose like in that situation what will happen, it may not detect means suppose some potholes or some animals before that car, due to some thing, then the driver has to immediately take the control, right? Now the fourth one is almost high automation, mind off. We can call it as mind off. So this is similar to level 3, but no driver attention is required for safety. Means it on its own it will do the these things, this accident detection, all those things. So the vehicle performs all the driving tasks under all these specific some circumstances. Like so, this is a level 4, but in level 5 we'll have this fully automation. No human intervention is required at all. Okay. So in 4 and 5, actually we need the things. We need to develop the automated vehicles with level 4 or 5, right? Okay, now coming to actually in our research, actually this is my research, whichever I'm submitted to some project, right? So in our project, we are trying to develop these. Actually, why this is challenging? Firstly, why this is challenging? So driverless cars require several systems to function properly, because if you observe, there are different challenges will be there. So based on some weather conditions, suppose while the vehicle is moving, suppose some rainy will be there. Okay, so if the human is there, if the driver is there, so we can easily, by taking care of something, and he can do some, he can slowly drive the car, or he will take care everything, right? But these are important things. This is an important condition. Weather condition is an important thing for autonomous vehicle. This is a challenging task, right? And if you see the traffic conditions and law, so we need to train, right? Suppose the traffic conditions, and suppose traffic conditions means what? Suppose blue light, red light. What is that? So we need to train the means that machine, right? So then this, if you see these road conditions also, like there may be some potholes or different kind of different obstacles, things will be there, right? And like one more important thing is to discuss. Suppose let's say, suppose two autonomous vehicles are there running on the road, right? So there may be signal. This what is this called? We can call signal interference between those two cars, right? Suppose this is also autonomous car. That is also autonomous car. Okay. So there may be some frequency. What is that called? Interference, right? So we need to take care all these conditions, right? Now coming to the this the problem statement. What exactly we are trying to develop in this particular project is actually to develop an efficient support systems that improve and fast track adaptation of self-driving cars, especially in the Indian traffic environment. Actually, some lot of research has been going on from the last I think from the last 1970s. Some research is going on in this particular area, but still there are a lot of existing what is challenges. There are a lot of challenges are there to address, right? Okay, so in our framework, actually we are trying to develop this for autonomous car. So the lane detection, because if you see in a while we are driving with a driver, suppose while we are driving, a driver is let's say is driving a car. So first he need to identify the lanes, whether he is going on the, suppose we can see that zebra lines, all those things, right? So we need to observe that. Then, our first concept, our first framework will based on this lane detection. So our model first detects the lanes, whether it will detects the lanes. Then after that, we are focusing on this traffic timer and counter detection. Suppose if we go to a signal point, okay, suppose we as a human we can see how what the timer and whether that is what is that yellow signal or green signal or red signal or whatever may be the signal, right? So green for go, red for stop, right? Orange for something something, right? So we have to train the system also, right? And one more thing, so counter detection. Counter will be there. Suppose there is red signal, so the counter will start from, suppose let's say 20, the next 19, next 18. So how much time we have to wait? As a human, we can understand, but we need to train the machine also, right? So in the second step, we'll do this timer detection as well as this counter, means what is the counter value, so that it will give the proper feedback to the machine, right? So that it will take the some decisions based on that. The next one is, next important thing is this. Suppose while going on the Indian roads, we can see lot of animals crossing. Means they are going on the road and they'll cross the roads, right? So we need to have a system.
Sir, Ajay sir,
Yeah,
please keep in full screen mode. Share
yeah,
full screen.
yeah. Right.
Yeah, thank you.
Mm. Right. So in in Indian conditions, we can see a lot of vehicles. They'll roam on the just roads, right? So our system has to detect those what is that animals, and because animals, they are also objects. We can't use simply an object detection model, because while going on the road, there may be trees, there may be rocks, right? But they are static objects. What are these rocks or these trees are static objects, okay? But this vehicle, these animals, okay, they actually they are not humans, right? They don't know whether vehicle is coming. Even though the vehicle is coming, they can't they will not take any decision whether we have to stop, whether the animal, it can't take the decisions, right? So as a human, we will take the decision whether that animal is coming out with what is the speed of that animal, whether it what in which direction it is going, right? So these things as a human we know, but how a vehicle will have to be trained. Okay, so that is our next module. Then the third one is so anyway, vehicular accident detection. Yeah, what is this vehicular accident detection? If you see multiple cars, multiple vehicles will go on the road, right? So the system has to detect. Suppose if it is going on some speed, so the front vehicle, how much with how much speed it is going. Okay, so based on that speeds, suppose if that front vehicle is suddenly, suppose some that due to some obstacle in front of that vehicle, it may slow down, right? So according to that, our vehicle also should slow down. Okay, so based on these based on this speed parameters, all those things. So it has to, the system has to detect. So how much speed the front vehicle is going, how much speed means I have to go, so that we can avoid this what is that called, accident, right? So anyway, here we are assuming these are one way, not two way, because in two way this is a little bit problem, because they are coming in other direction, these are going in different direction, right? Anyway, our research is confined to one way road. The last one is pothole detection. Yeah, potholes means these are some due to we know mainly in everywhere, in every city, every village, every town, wherever you go in India, you can see a lot of these things, right? So every time in rainy season, you can find a lot of these potholes, right? So the system has to system has to detect. So with how much distance that pothole is there. So and it has to what is the means what is the impact, so how much speed I have to go, and in which direction I have to take, either take to left or right, or so based on these potholes, so it has to detect that one, and it has to give the feedback to the machine, so that the machine will take the decision based on it, right? Now we'll see one by one. Yeah, actually, to implement all these frameworks, actually, as a single model, we implemented these as some different models, but finally, actually, we taken up only one Mars Garcian model to train these means train the system, and all these frameworks we implemented using Mars Garcian model. Right. We'll see what is Malkarsian. First, I will give you a brief this one, how we implemented this one using Malkarsian. First one, if you see lane detection, actually this involves a lot of computer vision technique. See, in the first step, suppose we can see these lines, white lines. These are the lanes, right? So first step in this one is, first we'll take the input frame, right? Then we'll enhance the image. Anyway, image processing people will know this, right? First we'll take the image, then it is enhanced, right? So then we'll apply some edge detection models. Means edge detection means what? So the edges, suppose if you see here, we have only black and white. This road is having black color, and this is having white color, right? So edges, so we have a lot of edge detection techniques like canny edge detection, right? So here anyway, we used canny edge detection model to detect these edges in this particular figure. So whatever, suppose if you see this is an edge, right? This is an edge. This mountain, this trees, these are all edges, sharp edges. Sharp. What is an edge? At the edge we'll have sharp color variation will be there. This sharp brightness variation, what we can call it as, right? Suppose from here sky and this is tree, so we can call it as the edge, right? Now here this one and this one, this is the edge. Now coming to this one, this is this footpath, and this is the road. So footpath is in different color, road is in different color. So there is a sharp variation. So right, this is called an edge. Now coming to this one, this is also color variation is huge, right? So this is an edge. Suppose if you observe here in the third image, so these are the edges observed from this given image, right? Now, anyway, for lane detection, if you see, if we put a camera in front of the vehicle, you can see the images like this. But if you observe, the top part of the image mostly consists of irrelevant data. Irrelevant data means we don't require the sky information, this trees information, right? We require only the road information. Means whether what about the lanes? The lanes will be on the down of means in the upper lower half of the image, right? So simply we will simply we will mask out this upper half of the image, right? So these are the first 4 steps. Now coming to the 5th one. Next, we'll apply some half transformation to transform these pixel dots. Suppose these pixel dots into some sharp, understandable lines. So means it will, the half transformation simply fills these gaps. These sharp edges are there, but there are some gaps are there. So this half transformation, we can use a kind of erosion and dilation techniques for filling these things, right? So Huff transformation will use those, right? So now these pixel dots are converted into understandable lines. Now these understandable lines are now overlapped with the original image. See, coming to this, these are the observed understandable lines, right? Now we overlapped those understandable lines over the original image, right? So now if you see from this one, the next step is locate the most dominant lines by taking the longest lines in the left and right slopes individually, right? So anyway, we implemented this one using OpenCV. Now the final thing is we calculate the smoothing moving average on the identified locations of the lines to get the final markings. So if you see, these are the final markings. See, up to this point we can identify now as the vehicle is going on, so this process will be continued, and based on that, so anyway, these are the identified lines for a particular sample image in our data set. Now let us assume our vehicle is here, it can identify the lanes up to this point. Now after going this point, it can identify the in the radius of sorry, in the distance of some 100 meters actually. We considered up to 100 meters. Right. Okay. Now this is actually purely we used for this one, purely we used here. There is no machine learning, there is no deep learning. Simply we used image processing for lane detection, right? Now coming to the traffic light signal and counter detection. Actually, this is the model. This is the model. Here, if you see this one, we used here whatever I said, the mask RCNN model. The mark RCNN model. The mark RCNN model, first the input image is given to this model so that it will give us the cropped traffic lights. Suppose the input image consists of what here? Our camera will take the this one traffic light image, right? So the mark RCNN, what it will do? First, it will crop the images, crop the traffic light part, only crop traffic light part. Right, I'll show you this demo also at the end for each these things. Actually, I have a video for this. Then these cropped traffic lights are given passed through a masking approach. Suppose if you see, you can have this model will consist of actually three steps here. First, we'll detect the traffic light. Right, traffic pole, we can call it as traffic pole. Then the next phase of this one is traffic color, light color. First one is traffic pole detection, then color detection. Finally, we'll detect the signal, the countdown timer value, pole, then light color, and if the light color is green or whatever it may be, red, what is the counter value, timer value, okay? So first we'll see how we'll detect these traffic lights. So for traffic light detection, we use this mark RCNN model, right? Then anyway, this architecture I'll explain after this, after finishing of this complete model. Now once the traffic light is detected, now we will retain only those detected traffic signals which have the detection score above a specified threshold. Okay, we have, suppose let's say the mark CNN model will give us a lot of input images, a lot of output images, but from that one, which we need to consider, which we need to ignore. So we will specify a threshold. So based on the threshold, if that particular image process means it is above the threshold, we will consider only that a traffic light. Then the input that the detected traffic light is converted to a RGB image. Right. Next, after that one, based on RGB, we can easily identify whether that is in red color or green color or blue color. Sorry, RGB images, we know color, right? Colors based on RGB, we can differentiate that HSV values, right? So based on those values, whether that light is red light or green light or orange light. Okay, so after that we need to next after we identified the color now, right? Then we need to identify the countdown timer, right? So to identify the countdown timer, actually just a minute, right? So to identify the, so convert first the given image is converted to RGB, then to HSV value. So based on these HSV values, you can say whether that is green or red or orange. Okay, right. Now after that, we will extract the features from that particular traffic lights. Then we'll perform some thresholding. Thresholding means converting the given image into binary image, right? Yeah. So we'll convert the given image into binary image. Then the binary image is then performed. We'll perform this. Will perform the masking over that image, masking between the original image and the threshold image. Suppose if you see this is the original image and this is a thresholded image. Threshold means binary image. So we'll get this one. We can call it as this extended cropped image. This is called extended cropped image. So the output of this one, we can now this particular this extended image, we can means we'll perform some pre-processing operations on that. Pre-processing operations on that, like normalizing and centering and scaling. Then this is passed through a retina model. Then this is passed through a retina model. So this retina net is again an internal. It is one part of the mask RCN model. So which will generate as these numbers. Like if you observe here, it will give us some numbers. So you can see here this 4,4. So extracted numbers from the extracted numbers from the traffic lights, right? So this is the complete result of our model. The first step is the initial image. If you observe,
Hello.
Sir, sir, I got the internet. No
Yeah,
problem.
yeah.
చిన్న బ్రేక్ అంతే ఏం లేదు వాడు సెట్ చేశాడు.
No problem, sir. Thank you. Share your screen and proceed your session, sir.
Yeah, thank you, sir. Yeah, is it visible, sir?
Yes, sir. Yes, sir. Proceed.
Yeah. So these are the results for this is one of the sample image we taken for this traffic light detection and timer countdown timer value detection, right? So anyway, now coming to the smart RCN model. So actually, this Mark RCN model consists of two stages. The first one is this CNN, that is this may be a ResNet or a VGG framework, right? So this is a convolutional neural network, and we'll have one more in stage one. We have one more network that is called RPN, Region Proposal Network. So if you see in stage two, we'll have this ROI aligned layer, and this ROI aligned layer generally predicts the object classes and also predict the bounding boxes. Suppose if you see here the bounding boxes, these are the bounding boxes actually, right? Now coming to this one, these are the some bounding boxes for all proposed regions, right? So then the masks are generated for each segmented objects in the mask branch. Okay. So anyway, we have these two stages here. Here we have CNN layer, and this is RPN, and here we will have in the stage two we will have this part. This part will have the ROI aligned layer, and the main purpose of this particular stage two is to predict the object classes, and mainly classes means what, whether this is a object or not, and what type of object it is, okay, based on this ROI, region of interest, right? And based on that it will frame a box, right? How does a mask or CNN work? So generally, the image is run through the CNN, first stage network, to generate the feature maps. Then this RPN uses a CNN. The output of the CNN will pass it through RPN to generate the multiple region of interest, multiple ROIs, using a lightweight binary classifier, a simple binary classifier. So the classifier, the RPN output will be either that is an object or a non-object. So it will generate some score. So based on the score, if the score is above some threshold, that is an object. If the score is below the threshold, that is not an object. So like that, the the purpose of the CNN, it will generate some feature maps. So the RPN will use a classifier that will returns the object scores. Okay. Next, the ROI aligned network outputs multiple bounding boxes rather than a single definite one, and wrap them into a fixed dimension. So the wrapped features are then fed into fully connected layers to make classification using softmax and boundary box prediction, right? So which is further refined using the regression models, right? These wrapped features are also fed into mask classifier, which consists of two CNNs to output a binary mask for each ROI. So the mask classifier allows the network to generate masks for every class without computing among classes, right? So anyway, the core of this mask RCN is the CNN layer, RPN, and ROI aligned layer, right? So based on that, we'll have, anyway, why I chosen this mark RCN is mostly in object detection will require some bounding boxes, right? So the ROIs. Okay, so actually this is the mask RCN framework. Now we'll see how vehicle to animal. Suppose a vehicle is going, right? Vehicle is running. If there are any animals in front of that, okay. So how to detect that animal? Animal is an also object, but that is a movable object, right? That is a movable object. So how these movable objects will be detected? We'll see now. So here, for object detection here. Anyway, I already said for all these all frameworks, for all these frameworks we use this mark conscience model, right? Here, the mask RCN network consumes a raw video frames of resolution 1920 by 1080 pixels, which are again these are implementation issues, I think, and they are sampled. The video frames are sampled at 30 frames per second, and which will give us what mask RCN give us. It will give us the bounding boxes, right? The bounding boxes has an output list along with their respective masks for the animals. Now, these animals are detected from the following categories. Actually, we mainly in Indian scenarios will have generally these cats, dogs, horse, sheep, cow, elephant, bear, zebra, giraffe, these kind of things, right? So we trained our model basically with these particular animals only. So which these animals we can observe in Indian roads, right? Generally, we'll observe in the Indian roads. How this will work now? Yeah. So for this, anyway, before anyway, if there is an animal, before to that, whether it is on the path of the vehicle or it is coming into the path of the vehicle. So these things we need to consider, right? So for that, to find out whether it is on the path of the vehicle, we need to first identify the lanes, right? So for lane detection, already whatever the technique we already discussed, right? The first one, the lane is used to determine if an animal is on the path of the vehicle or not of our autonomous vehicle. So, example. So, countryside animals which are not on the road are not relevant to the AV, means autonomous vehicles, right? So here, what is yeah. Yeah, if an animal is not within the lane, we use it as the backbone for predictive feedback mechanism of approaching animals. So if it is not on the lane, so we'll give it to another predictive feedback. So we need to predict whether it is approaching onto the road, okay, approaching the vehicle. So if it is not on the path, the next step is we need to identify whether it is approaching the vehicle or not. Okay, so for that we have here a backbone, the predictive feedback mechanism. Now, how these animals are generally identified? Anyway, we have some algorithms, object detection algorithms. So here we use one of that algorithm, that is centroid tracking algorithm. See, if an animal, that I think I will discuss in the next topic, because what is that? Animal to animal detection, right? So there also we'll use the centroid tracking algorithm, right, to detect an vehicle which is approaching which is on that particular lane of our vehicle, right? We'll see that centroid tracking algorithm in the next slides. Yeah. Now, if an animal is outside the lane but moving towards it, right, but moving towards it, we can alert the autonomous vehicle beforehand using the predictive feedback mechanism based on the following two conditions. So if you see, the animal is outside the detected lane, but it is moving in the direction towards it, right? The first one is it is not on the lane and it is outside the detected lane, but it is moving. We need to identify the direction, whether it is moving towards the direction of the vehicle or not. Next one is the animal is in the vicinity of the autonomous vehicle. Within the vicinity of the autonomous vehicle means very close. Okay, at that time, so what action to take, right? So these two things we'll discuss. So how to detect an animal, how to track an animal, whether it is approaching or whether it is in the vicinity of the what is this, a vehicle, right? So we use here the centroid tracking algorithm over successive frames as follows. Yeah, the centroids of the objects are determined by taking the intersection of the lines passing through the midpoints of the boundary boxes of the detected animals. Yeah, we have here the diagram, so we'll see how this will work. centroids of the objects are determined by taking the intersection of the lines passing through the midpoints of the boundary boxes of the detected animals. Next, suppose this is the centroid. Actually, this is the bounded box, right? So this is a centroid, right? This is a bounding box. This is the centroid, right? Now, the Euclidean distance is calculated between the centroids of the newly detected objects and the existing objects, right? Suppose what we are doing here between the detected frame, between the successive frames. Suppose now we detected a midpoint, right? Now we detected in the particular frame, actually that object is, that animal is moving, right? So for the current frame to the next frame, there is a little change, right? So for the first frame, we'll compute the centroid. Then for the next frame, also we'll compute the centroid, and we'll calculate the Euclidean distance. Now the coordinates of the existing objects are updated based on the shortest Euclidean distance from the current set of centroids and the previously stored centroid. So new objects in the field of view are registered by assisting a new unique ID and storing its centroid coordinates in a direction. Yeah, if you observe here, yeah. So suppose actually this is the centroid of that object. Let's say our vehicle is coming in this direction, right? And if an animal is moving towards the lane, suppose if you see this is perpendicular, if you observe our vehicle is moving like this, and the centroid, the movement change is horizontal. It means it is horizontal to the road, right? If the animal is moving towards the lane, and it is in which we can predict the animal is hazard for the autonomous vehicle even before it actually enters the lane. See, if you see here, animal detected at the beginning of the feed. This is the first frame, let's say. Now, predicted feedback before animal enters lane. So this is the predicted feedback. Suppose next in the next frame, what we'll get? That the centroid will move to here, and that is if you see that this perpendicular line will becomes very perpendicular. So that is approaching our that means what? That animal is crossing the road, right? So like that, we can say, we can give the indication to the system that some animal is crossing is approaching towards the lane, and we need to stop that vehicle, right? Now, yeah. So we are. This is yeah, a combination, the two stages. If the road is unobstructed, we give a go signal to the autonomous vehicle. If the animal is present within the lanes or near the lanes, as per the predicted, we give a stop signal, right? So if the road is means if there is nothing, means if there is the road is clear, right? If the road is clear, we give a go signal to the autonomous vehicle, right? But if an animal is present with our predictive feedback mechanism, then we'll issue a stop signal, right? So these are the different lighting conditions we observed, means in different conditions, like day condition, this is at night condition, this is at low light condition, at rainy conditions, right? So suppose if you see, actually this is detected here, right? But here we issued a stop signal here. So here also initially we can't detect this animal here, but we are anyway. If some object is there, then issuing the stop signal to this, right? This is how these bounding boxes will be there, means in the rainy condition, this lane detection, this is a lane, actually our vehicle is going towards this direction. Now the next one is vehicular accident detection. So vehicle to vehicle means this is vehicle to vehicle accident detection, right? Actually, these are the few steps involved in vehicular accident detection. The first thing is in the previous step, the first animal detection, then whether it is in the vicinity of the animal, vicinity of the vehicle, or whether it is crossing the road. So we implemented like that. But here, this is vehicle to vehicle. First, we need to identify that object, right? That is vehicle here. So vehicle detection. Then the tracking of the vehicle tracking. Again, we use here the centroid algorithm, centroid tracking algorithm. Then vehicle overlap. Then the lane detection, whether it is in the current, the present our vehicle's lane or not, right? Then the vehicle trajectory and the angle of intersection determination means this is to determine whether it is approaching the vehicle or what is the speed of that vehicle. These things we'll discuss here. Then the vehicle speed and change in acceleration determination, then accident detection. Right. So this is the flow chart for this. Actually, this is the video frame. Yeah. So here first what we'll do, whether any vehicle overlap means in front of this particular vehicle, is there any vehicle, right? No, take the next frame. If yes, so within the same part of the lane. So what is this? Whether that vehicle is in the same lane, right? Then what about the speed? What about if it is in the same lane? So what is the speed? Acceleration, right? So next, the trajectory information. So trajectory means whether the trajectory information. Then whether what is the angle of collision, with what angle it is going, right? So these information means like our animal here also. Suppose a vehicle with what will happen, a vehicle with brake failure, what will happen, it will go in different direction. But as a human we can identify, right? But if a vehicle is going in our lane and what the speed, with that speed and everything we can easily identify, right? But in this type of situation, we need to identify the angle of collision, right? So here first we'll see this based on the speed. So the maximum acceleration over next 15 frames, average acceleration in previous 15 frames. So what is this? Actually, based on the past data, what I said. So anyway, slowly our vehicle is going, means suppose a vehicle is moving in front of our vehicle, right? So our camera will take the video frames second by second. So it will observe with what acceleration it is going, right? So it will observe it will observe from the current time. So it will observe the next 15 frames and what are the previous 15 frames, right? So next, based on that acceleration information, it will detect an anomaly, right? So if that anomaly is greater than a threshold, then there may be a chance of traffic accident. So like here also, based on this information, this angle of collision, all those things, whether that is within the B box or this is bounding box, or whether this is 2 times within the bounding box, or whether that is outside the bounding box. So based on this information, this machine will, the system will predict whether a traffic accident may occur or not. So again, this is implementation part. Actually, this is the tracking vehicle tracking method. See here, the detected vehicles are tracked using the centroid tracking algorithm. So the Euclidean, we'll use the Euclidean distance between the centroids of the detected vehicles over consecutive frames. Okay, suppose the distance. This is one vehicle. This is the bounding box for the first frame. This is the bounding box for the next frame, right? So what is the distance? So based on that, you can see the acceleration, how much speed it is going, right? The speed, the distance we can calculate. So distance, we have the time, right? So based on that, we can calculate the speed of the vehicle, right? So based on that information, we can we can have whether there may be chance of accident or not. So vehicle overlap. The next one is vehicle overlap. This is also a cause for vehicle accidents, right? So in any vehicle accident, the two vehicles must collide. This means that in an instant, these two vehicles must be overlapping in a frame, in a particular frame. These two vehicles must be overlapping, right? So for that, this overlapping can be easily determined if the mass generated by the mass cars in are overlapping by taking the intersection over union, IOU. So the individual mass can be represented by on, 1 or off 0 pixels. So masks are made of yeah, height, width and instances. We use thresholding to flatten them and convert them into on or off. Then we take the area of intersection and area of their union. So to detect whether there may be a vehicle overlap or not. Yeah, so lane detection and section wise analysis. See here we have different vehicles here. See, this is our, let us assume this is different conditions are there. So S1, S2, S3, section wise analysis. Three different lanes are there. So see S1 is left side of the left lane demarcation. S2, between both of the lane demarcations. S3, this third vehicle. This is the first vehicle, this is the second, and this is the third. If you observe, this is right side of the right lane demarcation. Okay, so like that, in which direction they are, means in which particular means whether there may be overlap or they are in the same path or in the different paths. Like that, we can do the section wise analysis. Yeah, anyway, this is vehicle speed. These are some formulas based on speed and this what we require, speed and distance. We can find out the vehicle speeds. So this is about trajectory information. Trajectory information means whether it is changing any direction. Okay, whether it is changing any direction so that it may hit our collide our vehicle. This is about that. Yeah, I think it is 12:45. So I will first. Okay, anyway, these are the few results we got after means experiment with Python and OpenCV, right? Yeah, so we'll see some few results from this. So the main issues faced here is no, actually data sets are available. We mostly taken the data set from data set from videos, means YouTube videos. So these are the few results. Actually, we used this is the operating environment we used for experimenting this. Actually, GPU. Actually, I purchased a GPU, but due to this, what is that COVID pandemic, they have means they have not means as of now. Given the purchase order, everything, but as of now, I have not received that. Okay, this we experimented with simply Google Colab platform only. Yeah, these things also, the evaluation metrics, how we can evaluate any deep learning model or machine learning model. We need to evaluate using precision recall values, right? Right, the average precision, all those things. And main thing is accident detection and this one, traffic light detection. What is that? Animal detection. So we use two different parameters here. Detection ratio. Suppose in the detection ratio, detected accident cases, correctly detected accident cases versus, yeah, this is true positive actually, right? Truly positive. We can call it as in our simple terminology. So the detection ratio is actually our model detect how many incidents our model detected correctly and total accident cases in the data set. Right. Now this is false classification or false detection, means false. This is true positive. This is false positive, right? The second one is false positive. Means patterns where false alarm occurs, even though there is no accident or no, what is that called? No animal or no vehicle, right? So even though our system predict that as a vehicle, okay. So how many situations are like that? That is a false alarm rate, right? So fixed traffic light signal and counter detection. The results for this one are actually these are the few observations. Still, a lot of work is to do. Actually, we started in last January, but due to this Corona and everything, it was in the middle of my. These are the preliminary observations. Yeah. So with this for traffic light and detection and timer detection, actually with the mask RCN for only traffic light detection. This is for traffic light detection as well as counter detection, right? So the precision recall values are this, and for counter detection the success rate is 95.65. Actually we taken almost 10 videos for this, 10 YouTube videos, and this is the precision recall curves. Yeah, and this is for light, sorry, counter detection. This is for counter detection. So we have 0 to 9 numbers, right? So 0 to 9, we use it for counter detection, the RetinaNet model here. So the precision recall for each digit is this one here. And these are the average precisions. Right, so compared with some works, actually, only one method is there as of now for this counter detection, traffic lights. That is Sahitya. Some paper is there. They got the precision of good precision is there, right? But our framework actually, and the thing here is why the precision and recall values are high, because they manually detect cropped that what is that called traffic light, and then they detected the object, they detected the counter values, timer values. But our system, our framework, what it do, it will automatically detect the traffic light, traffic pole, and that it will crop that what is that the traffic light, traffic light, and it estimates the color as well as the counter, right? So these are the results with our model. I think these are not that much good. Still, no, actually, as of now, there is no model fully developed for counter detection for traffic lights. Okay, so that's why compared with only one. Right, now pothole detection. Yeah, pothole detection. This is also actually this is not our contribution, not our full contribution. Actually, we taken the model from the existing literature, and we try to, because actually we are trying to develop the system support systems for these autonomous vehicles, right? So first thing is fix it the traffic lights, then animal detection, then vehicle accident detection, right? All those things. So in the middle of means after few days, I got some idea. So potholes is also some important topic, right? So by clubbing, means by incorporating all these features, it may become a good model, right? It will become good system. So that's why actually I taken this particular pothole from others work. And for potholes also, there is no that what is that called data set, publicly available data sets. Data set is not available. Yeah, these are the few images for the potholes. Yeah, you can see here. These are the some few potholes here. And the available images also very less, so we use some augmentation technique. So what is that augmentation technique? Augmentation means we'll use some flipping method, cropping and rotation, scaling. Suppose a simple image will be there, right? That single image will be cropped to make another image. It will be rotated to make another image. It will be flipped to make another image. So for training purpose, for a deep learning model, we require actually a huge amount of data. But unfortunately, for this particular the means work, these potholes, there is no means available, publicly available data set. So that's why whatever the available images are there, we did some augmentation. So actually, this for potholes, mark RCN, we taken that and we implemented using this mark RCN. Right. These are the results anyway. Yeah, this is the comparison with others' work for potholes. Yeah, few potholes here. This one, this one, this one, and this one. Yeah. Yeah, this is the results with vehicle to animal detection. Yeah, approximately 80%. Yeah, for dogs, and this is for cows. Actually, we considered only two here because of for this also the taken YouTube videos only for getting the frames, means for as a data set. From that videos we taken we converted them into frames and try to identify these cows and whether they are approaching the vehicle or they are crossing the road, these things. This is for dogs. Only two, these cows and dogs we did here. Again, this is a comparative study. Yeah, this is vehicular accident detection. Still here, this is 77. This is 80 fresh. This is 71%. False acceptance is 59. Ours is 34. Right. Yeah. So these are the few results. Anyway, these are the conclusions. Right. Actually, lot of work has to be done. Means we also, due to this corona, it was in the middle of it is in the middle of means not completed fully. Yeah. So anyway, these are the conclusions. Yeah, no need to read, I think, because uh, again here what we'll have what is the precision average this recall values, right? Yeah, this is some future scope. Actually, the lack of data sets is the first thing, and experiment. This more analysis has to be done, and this comparative study is also required here, and this combining the overall system, because these are different frameworks, right? So we need to actually have a single system to detect all these things. Means potholes, vehicles, animals, traffic lights, everything, right? Thank you. Actually, these are few more means how we implemented, what parameters, how we tuned these parameters, all those things. Yeah. Anyway, this is the background about different what is that deep learning models. Yeah, please. Srinivas sir. Yeah, please. Any questions, please?
Yeah. Yes, sir. Yeah. Thank you for your nice presentation, sir. So we got some bit disturbance in the middle.
Yeah, middle of the this thing, and actually I have no time, sir. Sorry for because actually it was some problem, right? From the last 3 days, I was busy with some issue. Huh?
Yeah.
Actually, I have no time. Actually, after March, this is the time. Means never. I means I verified this PPT also. That was the main problem. Actually, I said you na, sir. Sorry, sir. I'll hand over the session to some other.
Yeah.
But anyway, okay. Anyway, sir, this is one of the area where we can use the deep learning.
Okay.
It is a promising area, right?
Yeah, I'm requesting the participants to get clarify our doubts with the speaker regarding the session. Please unmute yourself and clarify your doubts, or you can ask any inputs required for your research
Yeah,
in the academic profession.
yeah.
Or you just mentioned the scope of research in this particular topic, sir.
Right.
Uh, just mention it so that
Scope,
any,
right?
yeah,
Yeah. Actually, this is this area is new to all of us, sir, mainly because in computer vision, suppose in computer vision, because this is mostly based on computer vision, right?
yeah, yeah,
So the people who are interested in computer vision, suppose we can have this, because nowadays everything is automated, right? So the market also there is a huge market for these autonomous vehicles and robots, all those things, right? So we can have means we can explore these things more means as of now there is no fully automated. That's what I said in the beginning. There are levels of automation, but there are, as of now there is no fully automated vehicle. Okay,
yeah.
so we can have more research. We can do research on this particular topic, so to excel our means this so in different directions, like whatever you may suppose, I told you this thing, right? But in the beginning also, I told you, suppose ECE people, you can do with this thing, this frequency interference between different vehicles may be there. So you can have that, you can take that input also for do your research. So a lot of challenges are there, right?
Okay, okay. Thank you, sir.
Anything else, participants? Okay, we'll conclude the session. Thank you, sir. Thank you so much, sir, Dr. Aileya Kaveti, sir, for delivering the talk on deep learning for autonomous vehicles. Thank you once again, sir. Thank you for sharing your knowledge with us. Thank you.
So, sir, if you have any specific videos to work on this particular
Yeah.
topic,
Actually, I have videos, sir. I'll share with
yeah, share me
Srinivas,
so
sir.
that
Actually,
yeah,
we
send me
have,
so.
yeah. Actually, I tried, but due to time, no, actually, I'm unable to show you. But I have the videos for each and every these things. Whatever the simulated videos for this particular work.
Okay, sir. So that we will mail
Yeah,
to our
yeah,
participants.
yeah. Okay, sir. It's okay,
That
sir.
may helpful to them.
Correct, sir.
Okay, sir. Thank you.
Okay, sir. Thank you, sir.
Yeah.
Yeah. Yes, dear participants, that's about autonomous vehicle session. We'll take a break for lunch now, and afternoon session will start at 2 o'clock. Session on deep learning for sentiment analysis will be given by Dr. Nagesh sir. So afternoon we'll start the session at 2 o'clock. Just now we have forwarded the link for attendance and feedback. I request all the participants to fill out the form, and we regret for the inconvenience caused in the middle of the session.